this is kind of the basic version of that device. That device is much more complex in what we can do.
This is sugar.
Sugar, ideally it should be salt. So let's just stick with the, let's start with sine wave. This is smoother. So we're at 100 hertz right now. And here's the voltage, so this will pump.
Oh, they're vibrating.
And here we start to go. So I think it's slightly sloped. You can tell the sugar's kind of going that way because of the slope of the, but you can see it forming, right? It's, I don't know, let's go up in frequency. I wish we could, oh. See, that button should go up by 100 each time.
I think it was the other one.
Oh, I see.
Yeah.
There we go. Okay, 1500, let's see. Not changing much, huh? Still even more.
Oh, now you got it. Oh, holy smoke. Whoa. Yep. We did it. See? Yep.
Like that? Sounds really nice, huh?
So this is a function generator. It sends an electrical signal at a certain frequency, and so this is hooked up to this, which is I don't know the actual term.
Wave generator or wave driver.
Wave driver. Yeah. But honestly, it's essentially just a speaker.
Speaker without a cone, right?
Yeah.
And so right. So these waves, which we can customize how we want, basically go here, and then this vibrates very fastly, quickly, up and down. And depending on which wave you're sending, it will go up and down in different ways. That's then connected to the metal plate. So this is what you would call your Chladni plate. We have two plates right now. Right now the circular plate is connected, but we also have a square plate. And so as these waves are being sent, the whole system is moving up and down very quickly. We also have a bunch of salt just randomly thrown onto this. And so as we play with the waves, you will hear a very pleasant sound, and patterns will start forming. Maybe adjust it a little. As you can see, certain patterns have more. There we go.
Sounds great.
Woo! You need earplugs for this. All right.
Loud.
So it's very loud. Now you can see the patterns start emerging here. If we let it go a little longer, it would be even more clear. I think we probably have a little bit too much sand on the plate right now, and you can see that it's sloping this way a bit as we're coagulating all the salt in here. So it's not perfectly balanced. And there's one example of visualizing sound using a Chladni plate, and it's an example of Cymatics. That was at, which kind of wave did we have? Was it a sine wave?
Yeah, it was a sine wave at around 1200 hertz.
1200 hertz sine wave. So questions you could ask is, what happens if we use the same exact wave on a different type of shape, right? What are the mathematics and physics involved there? Will it produce similar patterns? What happens if we use a square wave at a different frequency? So these are the kinds of experiments you can do with these types of devices. Let's try to get all this sand onto this thing. Stuff. There we go. Kind of spread these out.
Rain. Okay, I have no idea what the frequency is for the pattern on this.
We don't know, that's even better. So we don't know which frequency is gonna give us a good pattern here. Spread it out a little bit more. All right, let's see what happens. see a pattern happening. Hyperbolic type of pattern. So instantly you can see that pattern. Now we have shown from previous attempts that this is not a unique pattern that happens here. There's actually this square plate produces all kinds of amazing patterns. So that's why people should come in and experiment with it and see what kind of patterns you can produce. Through this, you can tell that obviously there's a very loud noise that is associated with this particular setup. So you may be seeing in the background here a whole bunch of other things that we got going on. And the plan is, we're not quite there yet, is to hook up actually musical instruments to our own version of a Chladni plate so that we can actually go through entire musical tones and whatnot with whatever device you want. Right now we just have a controller hooked up to a DAW, which is also hooked up to some speakers and whatnot. And we also have some filters here through this machine that serves as effects, and you can apply, you know, delay and reverb and things like this to it. But the goal is we don't want to listen to that sound every time. So eventually, probably in the upcoming month or two, we will have the setup with the synthesizer hooked up so that we can actually hear nice music and see it change as you play each key. It should change right in front of you, these patterns. So,
Yep.
do you have anything else to add?
I don't think there's much else to add. Yeah. Okay.
Why is it that the patterns on the circle plate don't happen on the square plate? Like,
It's because of the way that the boundary is. So the waves will keep going, and then in here they kind of hit an edge, so they have to bounce backwards. And so because they bounce backwards, it creates sort of a meshing of the waves, which creates patterns like this.
Yeah, you kind of think of these corners here. You kind of see how it's, at least in this pattern, right? It's symmetrical to each corner. So the boundary plays a big role in the patterns. The thickness of the plate plays a role. The type of metal the plate is made out of plays a role. If you go over here, real quick, here is one that we were working on a while ago that we were going to use as a custom. We used the Chladni device a single time on this plate. This used to look silver. The whole thing was silver, and in fact, you can even see the corrosion here. Some of the salt is still stuck to the plate. So we don't want that to happen, right? We learned our lesson about which material of the metal plays a role, because it hasn't happened here, and that's because we were using salt. So maybe sand is a better method here. But you know, there is a way to get to the math and have these patterns be predicted based on the frequencies. So that's like high level math stuff, but I think if we're going to continue with the club, that could be something that is explored.
Yep.
You know?
Definitely.
okay,
Any other questions?
no.
Okay.